The morning of August 26, 2026, began with clear skies and dry ground along the Trishuli River Valley. Without monsoon rains or seismic activity, there was no immediate reason to expect a disaster. The Girong port sat at the center of the morning's activity. As a critical international gateway, it was crowded with trade convoys and hundreds of foreign tourists crossing the border between China and Nepal. That routine was shattered by an apocalyptic surge of mud and boulders. A wall of debris tore through the valley, crushing riverside structures. This data from the Galchi monitoring station shows the scale of the event. Downstream sensors recorded the water level jumping by a staggering 9 meters. The most terrifying detail was the speed. The river reached that 9-meter peak in exactly 30 minutes. The human toll was immediate. Rescuers confirmed 177 deaths, while more than 1,300 people remain missing, a figure that includes hundreds of foreign travelers caught in the surge. The flood also obliterated 15 billion rupees worth of critical infrastructure, sweeping away the roads and bridges that connected these mountain communities to the outside world. USGS sensors confirmed no earthquake. Local stations recorded zero rainfall. To find the water's source, researchers looked 40 miles north and 17,000 feet into the high alpine. The focus of the investigation shifted to the Lende Kola, a high-altitude tributary flowing through the peaks 40 miles north of Kathmandu. High on a steep mountain face, a section of a glacier measuring 2,000 feet wide cleanly failed, snapping away from the rock. The mass plummeted 4,000 vertical feet. By the time it reached the valley floor, the ice was traveling at a cataclysmic velocity. Geomorphologists point to a process called kinetic melting. The sheer energy of the impact generated enough heat to instantly liquefy the ice upon contact with the ground. This flash of meltwater violently displaced the existing river, rocks, and soil, churning them into a high-density debris flow that accelerated downstream. Gravity weaponized that structural failure, transforming solid glacial ice into a hyper-accelerated liquid surge before it reached the inhabited valley. As the surge moved lower, the narrow, V-shaped Himalayan geography acted as a funnel. The water was forced upward, reaching heights 270 feet above the normal river level. This amplified force completely destroyed the Maituri border bridge and leveled the Rasuwa customs office. The debris flow also crippled 6 major hydropower plants and transmission facilities, which were built along the riverbed to harness the Trishuli's natural flow. Once the high water surge passed, it left the valley floor blanketed under a thick layer of mud and boulders that buried entire settlements. Human infrastructure in this region is designed to handle seasonal monsoons, but those defenses proved useless against the brute force of a hyper-accelerated debris surge. Cross-border rescue operations mobilized immediately, with hundreds of soldiers and emergency workers navigating the unstable terrain to locate survivors. However, the danger remains. Avalanche debris has choked a narrow section of the river, forming a massive landslide dam. If this fragile blockage bursts under the pressure of the trapped water, a second catastrophic flood will hit the exact same communities. This is the reality of cascading hazards. Climate change is destabilizing the high-altitude cryosphere, creating localized failures that trigger massive, destructive chain reactions downstream. A destabilized peak can now rewrite the map of a populated valley in minutes. This makes cross-border early warning systems the mandatory starting point for survival in the modern Himalayas.